All right, here we go. Question 13 from our Calculus 1 homework number 3 in WebAssign. They want us to find the equations of both lines through the point 2, negative 3 that are tangent to the parabola y equals x squared plus x. And then we will have to put them in according to which has the smaller slope and which has the larger slope. So let's go to our scratch work and see how we're going to figure this out. So here's the thought process. We know that our tangent line has to pass through this point, and in order to write the equation of a line using the point slope form, you need a point, which we have, and the slope, which we can find by taking the derivative of our function. And since we're in chapter 3, I'm going to go ahead and use the power rule to find the derivative of this quadratic. That's going to give us 2x plus 1. Remember, the derivative is the slope of the tangent. And so now we can plug into the point slope form. We can say y minus y1 minus a negative makes that a plus equals m, which is this. 2x plus 1 represents the generic slope of the tangent to our curve, and then x minus x1. And this right here is an equation that represents where the lines are. Now, to simplify this equation, we're going to need to do the FOIL method, starting with 2x times x gives us 2x squared. We're going to have minus 4x from the outside, plus 1x from the inside, and minus 2 from the last. I'm also going to bring the plus 3 over, making that minus 3, so that I can isolate y, and then I need to combine like terms, giving us y equals 2x squared minus 3x minus 5. And now if you think about where we're at, okay, remember this was the line that passes through this point, but also has to intersect this curve. And so what we want to do now is we want to find where these two graphs intersect. And that'll give us our x coordinates for our points on the original curve. So to find out where these graphs intersect, we're going to need to set them equal to each other. Notice that y equals x squared plus x, but also y equals 2x squared minus 3x minus 5. And since y equals both of those things, I can substitute, and that's going to give us x squared plus x equals 2x squared minus 3x minus 5, and then we need to solve for x. Bringing the x squared and the x over, that's going to give us 2x squared minus x squared. I've got negative 3x minus x, negative 4x minus 5. And now for this quadratic, factoring is the fastest way to get our solutions. We're going to have x minus 5, x plus 1. Setting those equal to 0 and solving is going to give us x equal 5 and x equal negative 1. Remember, these correspond to the x values that are going to give us solutions to our original problem. And so if you're wondering where do we go next, this is the answer. We're going to plug those x values into the derivative, and that will give us the slope of each one of the lines tangent to our curve. So slope of the tangent is going to be 2 times 5 plus 1, and the slope of the tangent is also 2 times negative 1 plus 1. There's going to be two lines that are tangent to our curve and passing through the point we were given. And the first slope of the tangent is 11. And the second slope of the tangent is -1. And now we can finish the problem. Having our point and our slope, our first tangent line is going to be y minus a -3 equals m. I'm going to use the 11 first. X minus 2 and y minus a -3 equals -1 x minus 2. Simplifying, we're going to have y equals 11x minus 22 minus 3 minus 25 and -x, y equals -x plus 2 minus 3 minus 1. These are the equations that will be tangent to our original curve, which was y equals x squared plus x, and passing through this point we were given. And for fun, I want to use Desmos to prove that we're right. So if you look at what I have graphed, this is our original curve, which makes this parabola, and we wanted the tangent line to this curve passing through this point. And if you can see my cursor, one of those lines should go something like this, and then there's going to be another one that's really steep and touches our parabola way up here somewhere. I have no idea. Actually, I do have some idea when I graphed that. All right, so let's graph our first line, y equals -x minus 1. And you can see that that line does go through our point and is tangent to that curve. If I zoom in, you can see that that line is going to touch the parabola at only one point. That is the tangent line to the curve through this point. And then there was another, y equals 11x minus 25. And then if we look what's going on here, you can see that that line does intersect our point like it was supposed to. And if we scroll up and zoom in some, that is really hard to see there because it gets so close to being linear here. That is going to intersect at the point 5,30. And so again, this is just one way that you can use Desmos to verify your handwritten work. And then the last thing we want to do is use WebAssign to prove that we're right. So for the smaller slope, that would be the -x minus 1. -1 slope being smaller than a slope of 11. 11x minus 25. We're going to submit and see if we get the green check mark of success. And we did. And we're done. And so if you have any questions or comments about anything covered in this video, please feel free to leave those in the comment section below. Or you can text me. And thanks for watching.